Hello students, welcome to Educate. In the last video, we have discussed about Raoult's law. In this video, we will discuss about the numerical question based on Raoult's law, which frequently asked in 12th board examination. And this numerical question is also important for IIT main as well as for NEET examination. So guys, let's see. In 12th board examination, this question will directly ask. But in IIT main and in NEET examination, this question will ask in modified form. Let's see how to solve this question. Question is here, chloroform and dichloromethane. The two liquid, chloroform and the dichloromethane has been mixed and the vapor pressure of chloroform and dichloromethane in pure state has been given, and it is asking after mixing the chloroform and the dichloromethane what will be the vapor pressure of resulting solution. And in addition to that, question is also asking what will be the mole fraction of chloroform and the dichloromethane in gaseous phase. Okay, so let's see here. Vapor pressure of chloroform in pure state has been given. That is 200 mmHg. Vapor pressure of dichloromethane in pure state has been also given, that is 415 mmHg. This one, and weight of chloroform inside the solution has been given, that is 25.5 gram, and weight of dichloromethane inside the solution has been also given, that is 40 gram, and it is asking P total. P total will be how much? So you know P total, that will be, P total will be partial vapor pressure of chloroform plus partial vapor pressure of dichloromethane. How to find out partial vapor pressure of chloroform then? So that is vapor pressure of chloroform in pure state into mole fraction of chloroform inside the solution. Now this one is given, how to find out mole fraction of chloroform. So mole fraction of chloroform, that will be equal to number of moles of chloroform that upon number of moles of chloroform plus number of moles of dichloromethane. So firstly find out number of moles of chloroform and the number of moles of dichloromethane. So number of moles of chloroform, that will be equal to weight of chloroform inside the solution, that is 25.5 gram, that upon molecular weight of chloroform. Chloroform molecular weight how much? Here carbon 12 plus hydrogen 1 plus chlorine 35.5 into 3, that much gram per mole. Gram will cancel out. So mole inverse will go in the numerator, that become mole. So 25.5 and divide by this one, you can get the number of moles of chloroform. That will be 0.213 mole. Number of moles of chloroform 0.213 mole. In the same way, number of moles of dichloromethane you can calculate. So that will be equal to 40 gram. 40 gram dichloromethane is there. So that will be 40 gram, that upon molecular weight of dichloromethane 12 plus 2 plus 35.5 into 2, that much gram per mole. Gram will cancel out. Mole inverse will go in the numerator. That become mole. So number of moles of dichloromethane you can calculate, and that is came 0.47. 0.47. That much mole. Number of moles of dichloromethane. So now find out here mole fraction. Mole fraction of chloroform, that will be equal to 0.213 mole, that upon 0.213 mole plus 0.47 mole, that much. So in the number of when we will have to find out the mole fraction of chloroform, then we will have to divide the number of moles of chloroform by the total number of moles of solute and the solvent. So after solving, it will become 0.312. Know it, because here mole and mole addition, mole will cancel out. Now, so mole fraction of dichloromethane you can also find out 1 minus 0.312. That will be how much? That find out 0.1 minus 0.312. That will be 0.688. 0.688. So partial vapor pressure of chloroform CaCl3, that will be equal to here 0.312. That into vapor pressure of chloroform in pure state is 200 mmHg. 200 mmHg. So that will be equal to how much? That means 62.4 mmHg. In the same way, you can also find out the vapor pressure of dichloromethane. So vapor pressure of dichloromethane, that will be equal to mole fraction of dichloromethane, that is 0.688 into vapor pressure of dichloromethane in pure state is 415 mmHg. This one. Okay. So after multiplying this one, that will become 285.5. 285.5. So that will equal to 285.5 mmHg. So you got partial vapor pressure of chloroform, that is 62.4 mmHg, and partial pressure of dichloromethane, that is 285.5 mmHg. So P total will be how much? P total, that will become equal to 62.4 mmHg, 62.4 mmHg, that plus 285.5 mmHg. This one, add this one, what will be there? So after adding, that become 347.9 mmHg. So the total vapor pressure over this solution will be 347.9 mmHg. Total vapor pressure, that means the partial vapor pressure, that means chloroform will exert a pressure of 62.4 mmHg over the solution, and the dichloromethane will exert a pressure of 285.5 mmHg over the solution. And so total vapor pressure exerted over the solution will be summation of the partial vapor pressure of chloroform and that of dichloromethane, which became 347.9 mmHg. Okay guys, now let's see about what will be the partial vapor pressure, what will be the mole fraction of chloroform and the dichloromethane in vapor phase. So P total, this one we need, so that's why this one I am keeping and remaining I am rubbing here. Now let's see what will be the partial vapor pressure of this one in vapor. What the meaning is actually here. That means it is a solution. In this solution, there is 25.5 gram chloroform, 25.5 grams chloroform, and how much? 40 gram dichloromethane. Question is asking, so mole fraction inside this solution we have calculated. Question is asking, when here it is vapor, in the vapor phase there will be some particles of chloroform and some particles of dichloromethane. This one, and it is asking what will be the mole fraction of this chloroform and that of this dichloromethane. P total we have calculated. So we know that partial vapor pressure of chloroform, that will be equal to P total, that means total vapor pressure over the solution, into mole fraction of chloroform in the vapor phase. Mole fraction of chloroform in vapor phase. So partial vapor pressure of chloroform we have calculated, recall there, that was 62.4 mmHg. And total vapor pressure we have calculated 347.9 mmHg, 347.9 mmHg into mole fraction of chloroform. So mole fraction of chloroform in vapor phase, that will be 62.4 mmHg upon 347.9 mmHg. Solve this one. After solving, you will get the mole fraction of chloroform in vapor phase, that will be 0.18. Mole fraction of chloroform, here mmHg and mmHg has cancelled out. 62.4 upon 347.9, that will be 0.18. In the same way, we can, as we have calculated the mole fraction of chloroform in vapor phase, and in the vapor phase there will be only two components, that is chloroform and dichloromethane, of which the mole fraction of chloroform we have calculated, and we know mole fraction of here chloroform and dichloromethane, that will be equal to 1. The summation of the mole fraction of chloroform and that of dichloromethane will be 1. The mole fraction of chloroform we have calculated 0.18. So 0.18 plus mole fraction of dichloromethane, that will be 1. So mole fraction of dichloromethane will be 1 minus 0.18. What will be there? So subtract this one, it will come 0.82. Okay guys, hope this numerical questions you have felt easy to solve. Okay, now let's see, proceed on the next topic. This topic is here asking that Raoult's law as a special case of Henry's law. What you have studied in Henry's law? That is, the solubility of gas in a liquid will be directly proportional to the solubility of gas in a liquid will be directly proportional to the partial vapor pressure of that gas over the liquid. And the Raoult's law states that the mole fraction of any liquid will be directly proportional to the partial vapor pressure of that liquid over the solution. That means, and here the relationship between the mole fraction and the pressure, there is the relationship between mole fraction and the pressure, which are directly proportional. Henry's law also states same thing, and the Raoult's law also states the same concept. So both the laws are same, but the difference is that the Henry's law is applicable for the solubility of gas in a liquid, while the Raoult's law is applicable for the solubility of liquid in a liquid. Okay guys, very easy. Now let's see vapor pressure of solutions of solids in liquids. Okay, before that let's see. There is a container, and in this container there is water. So everywhere there will be the particle of water only, and in this container you have dissolved sugar in water. So what will happen? Sugar will also get uniformly distributed. So at this surface there will be a particle of sugar and the particle of water, both. There should be, in the pure liquid, there is the particle of only liquid which can undergo in the vapor phase. And here you have dissolved a solid in liquid. You have dissolved solid in liquid. So at the surface there will be some particle of solid and some particle of liquid, of which the liquid will undergo in vapor phase, but the solid will not undergo in vapor phase. So in the pure liquid, more and more particle could undergo in vapor phase, but in the solution all the particles will not undergo in vapor phase. So the vapor pressure of solution will be lower than that of pure liquid. So of the solution, when a solid will dissolve in a liquid, the vapor pressure of resulting solution will become lower than pure liquid, because some of the solute particle, which is solid, because some of the solute particle will displace the liquid solvent particle from the surface. That's why the vapor pressure of resulting solution will become lower than pure liquid. Okay, that was about this one. So question asked, why the vapor pressure of solution is lower than pure liquid? That's the questions asked in 12th board examination. Give reason. In the 12th board examination, question will be give reason, and one of them will be the vapor pressure of solid solute and the liquid solvent is lower than that of pure liquid. So you will have to write in when a solid will dissolve in a liquid. When a solid will dissolve in a liquid, the solid particles will displace the liquid solvent particles from the surface. The solid solute particle will displace the liquid solvent particle from the surface. That's why the vapor pressure of solution will become lower than pure liquid. Okay, now let's see about this graph. What this graph is stating. Suppose here is salt. In this container I have taken a salt, and here in this salt we will add water. It is liquid, it is solid. This one is solid and this one is liquid. Now, so when you plot the graph, initially at here, there is no liquid, so vapor pressure will be 0. This is vapor pressure and it is the mole fraction of solvent. So in this container, when there is solid, the mole fraction of liquid is 0. So vapor pressure will be 0. Now you add the liquid. So the mole fraction of liquid, solvent will increase. So vapor pressure will increase. Again you add water. Again mole fraction of liquid, because the solid particle is same and the liquid particle is increasing. So mole fraction of liquid solvent will increase and the mole fraction of solid solute will decrease. And the vapor pressure is directly proportional to mole fraction of solvent, because only liquid particle will undergo in vapor phase. Salt which you have taken, that don't undergo in vapor phase. Only when you dissolve this liquid, when you will add this liquid in this container, then the vapor pressure will increase, because only this liquid particle will undergo in vapor phase. So you have added, so vapor pressure increases. Again you add, so mole fraction of solvent will increase and that will also increase. And finally, so the mole fraction of solvent and the vapor pressure, that is directly proportional. So this one here, mole fraction of solvent is 0, because there is no liquid particle here, and here mole fraction of solvent is 1. So at that state, the vapor pressure of that liquid, what happened when you have added more and more liquid water, so that after a state, the amount of this salt will become negligible compared to the amount of this liquid solvent. Then the mole fraction of this liquid solvent will be equal to 1. So that will be equal to the vapor pressure of that solvent in pure state. So that is vapor pressure of that solvent in pure state. Okay? Hope this concept is clear for you. In the next video, we will discuss about ideal and non-ideal solution. Thank you, Team Educate.